So hey guys, welcome back to another video. Today we'll be exploring some more system design topics. Which the first one is idempotent operations. So what is the idempotent operations? The spelling it pronunciation is a little difficult, but what it means. So idempotent operations are operations that can be applied multiple times without changing the result beyond the initial application. So which means that if you have any function, let's say if there is some function, and if I call a function inside function, still the result should be fx. Okay, this is the mathematical definition of idempotent operations. It's from Stack Overflow. Let me open that. Let me show you what it is. So if you see in computing, an idempotent operation is one that has no additional effect if it is called more than once with the same input parameters. For example, removing an item from a set can be considered an idempotent operation because set has unique set of elements, right? And if I try to call, let's suppose if I try to call remove in bracket I write 2, so 2 is removed one time, and again I call, it will have the same effect, right? It's already removed, so it won't perform anything. In mathematics, an idempotent operation is one where fx equal or function called inside a function is function only. The results are same. It doesn't matter what number of times it's called recursively. So for example, abstract function is idempotent because abstract of abstract is equal to abstract of x for all x. That is what it is. Okay, now that is idempotent operation. It is also important to understand that benefits of idempotent operations, especially when using message or task queues that do not guarantee exactly once processing. Many queuing systems guarantee at least once message delivery or processing, right? Every queue system that we create, let's suppose there is a queue, right? We have created a queue. Whenever we put something inside this queue, it's guaranteed that it will be delivered to the end user. Okay, it is guaranteed. Now it's not guaranteed, but it depends, right? Even if let's suppose I have pushed some notifications. Let's suppose that I have pushed notifications, 10 push notifications, right, in this queue, and it takes our server, which is S1, tries to pick it one by one, right? And once it pick one by one, what happens if there is any notification is failed to send to the end user, suppose this is our end user, what it will do, it will send a message to the front end that this notification backend was failed to send this notification, and it will sort of show an alert that this was failed operation, right? These systems are not completely synchronized, for instance, across geographic regions, which simplifies some aspects of their implementation or designing the operations that a task queue executes to be an idempotent allows one to use a queuing system that has accepted this design trade-off. Okay, now that was about idempotent operation. You can go in more detail, you can learn more about that, you can get some more definitions what it is. It's a secret operation, right? Now what is the next topic? Next topic is about communication, right? Let's suppose, what is communication, right? Communication, the network calls, how our server communicate with each other. So what are the protocols they use to communicate? We'll learn about that, right? So what is communication? Network protocols are a key part of systems today, right? Network protocols are key part of systems today, right? As no system can exist in isolation, no system can work on its own, right? There is communication is needed between systems to make sure that everything is working fine, right? They all need to communicate with each other. You should learn about networking protocols such as what are networking protocols? Networking protocols are like HTTP, TCP, UDP. These are in Windows. If you try to see, you will know that. We will also learn about architectural styles such as one is RPC, REST, GraphQL, and gRPC. RPC means remote procedure call, and we will learn about this. Let's learn about this. So that was about communication. Now let's first learn about what is HTTP. HTTP is the most common protocol we used in our API calls as well, right? So HTTP, but it is an expensive API call, right? So what is HTTP? let's learn about HTTP. So HTTP is a method for encoding and transporting data between client and a server. So this is a protocol which is used to transfer data between client and server. So the data exchange happening between client and server is using HTTP protocol. It is a request response protocol. So what we do, our client sends a request, right? So this is our client. Suppose this is our client. This sends a request and we get back some response from server. Okay. So this is what request response model looks like. Clients issue request to the server and server issue response with the relevant content. That's what it does, right? Now, and completion status info about the request. So it will send the response with like 200 status code 500 or 501 or 405. There are many status code. It indicates the if server was able to resolve the request or not. So 200 to 298 or whatever 299 is the success response depending on what type of content was able to proceed with. Now, HTTP is self-contained, allowing request and response to flow through many intermediate routers and servers that perform load balancing, caching, encryption, and compression. So as we learned in our previous videos as well, that what load balancers are, right? So HTTP protocol is also used to communicate between load balancers, right? Load balancers, routers, middlewares, if there is any middlewares, and encryptors if we are using any, right? Encryptions, compressing the data before giving it to the server, and caching as well. So caching is also if we are using any other CDN or anything, then caching as well, it is used in communication. A basic HTTP request consists of a verb, method, and resource endpoint. Below are some common HTTP verbs. So what are common HTTP verbs? Let me show you that what are some of the common HTTP requests. So HTTP requests, some of the common are like it's a get request, post, put, patch, and delete. Patch is also known as sometimes update, not update exactly, but yeah, patch partially updates a resource. So it partially updates a resource. Put is for updating or replacing a resource. Post is for creating a resource, and get is for reading a resource. Okay, and the delete is of course deleting a resource. So the delete can be of two types. It can be actual delete, hard delete, or hard delete. It can be soft delete, means we will just update the flag instead of deleting the entire item for research purposes. Now HTTP is an application layer protocol relying on lower level protocols such as TCP and UDP. So HTTP relies on what? It relies on TCP and UDP. Now what are TCP and UDP? Let's learn about that. Okay. So this was about HTTP protocol. Okay, HTTP Hypertext Transfer Protocol. That is the full form of HTTP. Now let's learn about TCP. Okay, what is TCP? HTTP relies on TCP and UDP, right? Now let's learn about what is TCP and UDP. So first let's learn about TCP. Okay, TCP is what? TCP is a connection, but let's first learn what's the full form of TCP. Transmission Control Protocol. TCP is Transmission Control Protocol. Let me write it here. Transmission Control Protocol. Okay. TCP is a connection oriented protocol over IP network. IP is Internet Protocol, right? So IP network connection is established and terminated using a handshake. So it's a connection oriented protocol over IP network, and the connection is established and terminated using a handshake. Now handshake is what? Right? Handshake is globally widespread brief greeting so handshake is basic handshake is a different thing, but handshake for telecommunication handshake is a different thing, right? In computing, a handshake is a signal between two devices or program used, for example, authenticating, coordinating. An example is like handshaking between hypervisor and application in the guest virtual machine, right? So what happens here? Handshake is like if I connect my device, I connect two Bluetooth devices, right? So there is some sort of handshake for authentication, which is OTP, right? We try to authenticate a device using OTP or any password. So or matching the codes, right? So we connect to a Wi-Fi or a network. That is also type of handshake, right? So TCP is also a type of handshake. The connection is established and terminated using a handshake. All packets sent are guaranteed to reach the destination in the original order without corruption through, right? So in TCP protocol, whatever packets or whatever data we send to any device, it is delivered in the same order. If it's the first, if it's the second, then it first will get delivered first, second will get delivered on second. Okay, so that is like what can we say, it's queue. It's a queue sort of thing. Whoever comes first get delivers first. Okay, so that's a queue, first in first out, right? FIFO pattern. Okay, now sequence numbers and checksum fields for each packet, and if the sender does not receive a correct response, it will resend the packets. Let's suppose this is our sender, right? If sender does not receive a correct response, if after sending this it does not receive a correct response, it will resend it. It will resend the packets. If there are multiple timeouts, the connection is dropped. TCP also implements flow control and congestion control. This guarantees cost delays and generally results in less efficient transmission than UDP. So what happens? TCP also implements flow control and congestion control. What is a flow control? Let's learn about flow control first. So flow control in data communication is the process of managing the rate of data transmission between two nodes to prevent a fast sender from overwhelming a slower receiver, right? So as we learned about in queue, right? If a queue keeps on getting filled, it will get overloaded, right? So what we do, we use back pressure. But here here also it's same, right? If sender is sending 10 packets per minute and receiver is designed in such a way that it only is configured to serve 5 packets per minute, so it will get overloaded, right? So flow control helps in managing that. It helps that it does not get overloaded, receiver doesn't get overloaded. Flow control should be disguised from congestion control, which is used for controlling the flow of data when congestion actually occurs. Congestion means what? Congestion means, so congestion, the state of being congested. Congested means being overwhelmed, right? The new bridge should ease of congestion in the area. What does congestion mean? Overcrowding, right? So overwhelmed sort of, right? Now, so flow control is also configured for TCP connections. Okay, so flow control is configured. Okay, flow control and congestion control is configured for this. Now what else? That was about it. Now to ensure high throughput, to make sure that our receiver serves as many requests as it can, web server can keep large number of TCP connections open, right? So what web servers can do, web servers can keep TCP connections, large number of TCP connections open, 1, 2, 3 or n number of TCP connections can be opened to serve large number of requests, right? Resulting in high memory usage. Of course, RAM will be utilized. So RAM will be utilized in high demand. It can be expensive to have a large number of open connections between web server threads and see a memcache server, right? Memcache server we learned about earlier as well. It is for caching. It stores key value pairs and all, right? So connection pooling can help in addition to switching to UDP where applicable. So UDP connections can be switched. Now what is UDP? We'll learn about after this. TCP transmission control protocol. TCP is useful for applications that require high reliability but are less time critical, right? So reliability, if the application has high reliability and time is less critical, time is not an issue for it. Like at whatever time the server responds, it doesn't matter, but it wants to make sure that the data gets processed. It's like we just put it in a message queue and it will keep on computing it in background tasks. So in that type of web servers, TCP is useful. Some of the examples can be web servers, database, SMTP protocol, file transfer protocol, and SSH, right? So it can be examples which use TCP protocol are web servers. Of course, web servers do use, if you host it on a Windows server or anywhere else. DB, database, SMTP. What is SMTP? Simple Mail Transfer Protocol. Okay, Simple Mail Transfer Protocol. What is FTP? FTP is File Transfer protocol. Okay, now after FTP, what SSH, right? SSH is secure shell. Full form of SSH is secure shell. So SSH is also a type of encryption, but yeah, let's learn about after this. Secure shell. So that was about TCP transmission control protocol, how it works, and what we have seen that sender receives this. Sender keeps on sending the packet. So flow control and congestion control is implemented to make sure that it doesn't get overwhelmed. To ensure high throughput, what we can do, we can have n number of TCP connections open so that it can serve as many requests as it can. And if it is implemented in the type of system where delivery is necessary but time is not an issue, time it can take, the system should be less time critical, right? It can, even if it should not matter if it's time, it should forget like once it's in the queue, it should get delivered, right? So if that is the requirement, then we can use TCP. Now what is UDP, right? UDP. What is UDP? UDP stands for User Datagram Protocol. UDP is connectionless and faster, sending data packets without the overhead of establishing a connection, but it does not guarantee delivery or order, right? So UDP is connectionless, right? It is connectionless and it sends all the packets and all. So datagrams like analogous or to packets are guaranteed only at the datagram level. Datagrams might reach their destination out of order or not at all, right? There is no guarantee that if your packet or your data will reach to the destination, right? It's not guaranteed here. Like it's guaranteed in TCP, it's not guaranteed here. And order is also not guaranteed. Order is also can be random, right? Order can be random. Without guarantees that TCP support, UDP is generally more efficient. How it is more efficient? UDP can broadcast sending datagrams to all devices on the subnet, right? So what UDP does, this is a UDP protocol. It broadcasts everything, sending datagrams to all devices. So it first it broadcasts everything and then all devices receives the data. This is useful in DHCP because the client has not yet received an IP address, right? Thus preventing a way for TCP to stream without the IP address, right? Because without IP address, TCP cannot stream, but UDP can because it's a broadcast channel, right? UDP is less reliable but works well in real-time use cases such as VoIP, video chat streaming, real-time multiplayer games. So UDP is good for if you want to stream anything. If there is a streaming device, then you can use UDP protocol. VoIP. What is VoIP? So VoIP means, I think it's something related to VoIP full form. VoIP full form. VoIP means voice over internet protocol, right? So voice over internet protocol. Video chat streaming and real-time multiplayer games, right? So UDPs can be. So what happens? We do not establish here in UDP. We do not establish any connection. It broadcasts everything without having connection, but it does not guarantee delivery or order, which is guaranteed in TCP, right? So that is one thing. This can be used voice over internet protocol, right? Video chats, so it can use for video chats. It can be used for real-time multiplayer games. So you have played COD, right? COD or Clash of Clans, which is also COC, Clash of Clans. You might have played Valorant. These are multiplayer games, right? So this can be played over UDP protocol, right? So this is real-time multiplayer games. This can be managed over UDP protocol. Now use UDP over TCP when to use UDP over TCP. Use UDP over TCP when you need lowest latency, when time is critical for you, right? You need low latency over network. Late data is worse than loss of data, right? Late data is an issue than lost data. It means that you have the data, it's just that you want the delivery to be faster. That's more priority for you. That's you want to implement your own error connection. If you want to implement your own error connection, in these scenarios, you can use UDP over TCP protocol. Okay, so that was about UDP, TCP, and HTTP. Now let's learn about RPC. What is RPC? Remote procedure calls, right? What is RPC? Sorry. So client causes a procedure to execute on a different address space, usually a remote server. The procedure is coded as if it were a local procedure call, abstracting away the details of how to communicate with the server. RPC, let me just open another definition. RPC